In our industry, we make things up and we wholeheartedly believe them. And then we tell other people this is the way that it is. And then they believe it. We pass these misnomers down and we're like super passionate. But when they're proved wrong, we're not as passionate about our apology as we were about what we were wrong about. And that's where I am trying to change, because I was like, hated heat pumps and I thought they were just inferior technology. Now I'm like, yeah, I was really wrong about that.
Hi, and welcome to the Heat Pump Podcast. Our goal is to make sure the transition to heat pumps goes well for everyone, homeowners, contractors, and the planet. Today, we have the legendary Jim Bergmann. He's the founder of TruTech Tools, the founder of measureQuick, a frequent guest on Brian Orr's show, and virtually any other HVAC show. He was also a heat pump hater, his words, not mine. And he went through a religious conversion with heat pumps. Again, his words, not mine. He describes how he feels about his own heat pump in his house, and from that, you'll understand why he describes it as a come-to-Jesus moment. In typical Jim fashion, we talk at a very high level about heat pumps, and then we delve very deep into the technical specifics of sizing and installing heat pumps correctly. It's a great conversation with practical and actionable advice for anyone in the heat pump space. Enjoy the show, and I'm really sorry about the singing.
You know, I only do singing intros, right? You got to sing my intro in.
And I'm super tone deaf, so I'm
Okay.
really excited to do it this way. Welcome to the Heat Pump Podcast.
Thank you very much.
Welcome to the Heat Pump Podcast, where we tell the stories of entrepreneurs who are building the businesses that fuel the shift to fully electrified homes. I'm Ed Smith.
And I'm Eric Fitz. We are co-founders of Amply Energy.
Today, we have a man who needs no introduction in the HVAC space. We have Jim Bergmann.
Thanks for having me out.
We got some good topics on deck, oriented around heat pumps. But before we get there, we'd just love the Jim Bergmann story of your career in HVAC through founding measureQuick and where you are now. But
yeah, and
I love the long version.
I've been doing this my whole life. My dad was a HVAC technician. He was actually a refrigeration mechanic. He was on submarines in the Navy. I grew up from the time I was about 3 years old, riding along with my dad and learning HVAC stuff. My mom was sick. She had epilepsy. She couldn't handle all the kids. I just rode around with my dad and learned a craft. My dad did not want me to go into HVAC. He wanted me to get my degree in engineering. And I coaxed him to let me do it so I could pay my way through college. He let me go to the vocational school. I graduated at the top of my class out of that, then went into the Navy to get the GI Bill and did heating and air conditioning in the Navy. Went to the University of Akron, spent 3.5 years in an engineering school and went to do my internship. And I was making too much money to take an engineering job. Left school, stuck out in heating and air conditioning. So I got this sort of unique background because, in fact, the only thing I didn't finish in college was Eastern Civ and Western Civilization. And I got through all my engineering classes, all my calculus, all my science, all that stuff. I've got this engineering background, but I've got a passion for commissioning equipment. I was working for the train company in Cleveland, and basically we did all the factory startups. I got to see everybody else's work, and I got to start up everybody else's equipment. And we did all the factory startups, spent my time in the union. I did a little bit of everything. 12 years of teaching, high school. And then about 2006, the iPad came out. And I remember looking at that in my classroom thinking, man, if I could just get a display as nice as that iPhone on my meters. Led to, now we got the tools talking to the iPad. Man, if we could just do some calculations and then reporting and then diagnostics, and then it just was this whole metamorphosis. And I've been working in the software world now for about 7 years, designing measureQuick. I did a little project called iManifold before that. So I really pioneered Bluetooth tools on smartphones. I've got some of the first patents on that. Pioneered smart probes, and then developed out measureQuick, which is a multi-tool platform that allows about 10 or 12 different manufacturers' tools to talk to the iPad all at once. All different manufacturers can work at the same time, so we can have a complete solution. And we've been working on measureQuick primarily around diagnostics, commissioning, making technicians more productive, reducing callbacks, that kind of stuff. A lot of time just around education, engineering, product design, product development, and trying to make people's lives better.
And a brief stint founding TruTech.
Oh, yeah, I did that too. Yeah, so a lot of measureQuick's development. Yeah, I started TruTech Tools with my dad. It was an interesting business because my dad and I went to Germany when I worked for Testo. At one time, I was teaching school, owned TruTech Tools, and was working for Testo as a technical specialist. And so I had all three jobs, and I wrote 28 articles for 7 different trade journals that year. So
Wow.
I was super excited in the industry. I started TruTech Tools. No internet company for Testo had done over 35,000. We did 70 some thousand the first year. And then year 2, we did 768,000. And then we did 1.3 million. And we were Testo's largest distributor. And then that company will probably do 25 to 30 million this year in sales. They exited, I guess, about 6 years ago or 7 years ago now. So they've done a little bit of everything. TruTech, it was really about being process focused instead of product focused. A lot of people sell tools and sell solutions, but they don't really focus on the why. Like, why do we do this stuff? And a lot of that was about intimately understanding the processes that people had to do and putting together a toolkit that would allow them to achieve that goal successfully. Because nobody had really thought through the whole process. If you're going to do an evacuation, what tools do you need? What hoses do you need? What kind of gauge do you need? What kind of connector do you need? What kind of couplings do you need? What brass fittings do you need? So we're packaging all that stuff up together and really selling the solution rather than just the product itself.
I love that the evolution of your experience and background, where you've gone from being intimately involved in figuring out what are the right tools to just get the measurements, to now figuring out, okay, we can measure some stuff. What does it actually mean? What is our target? How can we use these tools to create an outcome for a customer or for this equipment or whatever the scenario is, to actually really create some value instead of just being like, how do we measure? It's a good starting place, but it's certainly not the whole story.
That's probably my claim to fame, I think, in this whole industry. I had a student where we were calculating airflow, the sensible heat formula. And he goes, "Hey, Bergmann, if we could rearrange that formula and measure the airflow, could we calculate the BTUs?" And I'm like, "Yeah, sure, Matt. Let's go out in the shop and I'll show you how to do that." Well, it led me down a giant rabbit hole because measuring airflow in residential systems was like impossible. Then all of the other elements, air density, temperature, barometric pressure, humidity, elevation, all these other factors came into place that were screwing with my airflow measurements. And I was so frustrated with trying to get this problem solved. And then I got introduced to Testo that spring, and I got a vane anemometer and a hydrometer. All of a sudden, my humidity and temperature measurements became really accurate, and I can accurately measure airflow. All the science started to actually work. But then it came across the next big thing was one day in a classroom. Again, I'm looking at a diagnostic chart, and it said for overcharge of a system on a fixed orifice, you'd have high suction pressure, high liquid pressure, low superheat, high subcooling. And so one of my students asked me, "I know if it's way too high or way too low, but how do I know if it's where it should be, exactly where it should be?" And I realized, man, I've been doing this for 15 years. And I never asked myself that question. I didn't really understand what should the pressures be on the gauges. I'm thinking, why am I even hooking up the gauges if I don't know what the pressure should be? Everybody's talking about the precision of digital. What difference does it make if you have a precise measurement if you don't know what the measurement value we should expect? I know my temperature should be 98.6, and I know if it's a few tenths or a degree one way or the other, there's something going wrong. Yet with air conditioning, you're hooking up the gauges and people don't even know what the pressure should be. And the pressures drive the temperatures, which are the driving force for heat transfer and refrigeration. It's like, God, we should know this. And so that's really what measureQuick was designed around. If we're going to make a measurement, it's got to have a target or it's got to have a use. It's not going to be in a vacuum anymore. All these other apps out there, when you hook them up, they tell 118 and 350. Okay, that's nifty, but what does it mean? Is it high? Is it low? Is it changing? Is it stable? When we really started designing software, started designing measureQuick, we realized people have to commission equipment under a variety of conditions. It could be 60 degrees in the house, or it could be 85 degrees in the house. It could be 0 degrees outside, or it could be 120 degrees outside. And the design stuff we see in textbooks where they're telling us it's going to be about 118 pounds on the low side and 300 pounds on the high side. That's for AHR design conditions. And how often do we work at AHR design conditions? Almost never.
Right.
What it really came down to, a couple of things. It's just like learning about design temperature differences. How much colder is the evaporator coil than the return air, and how much hotter is the condenser than the outdoor air. When I was in education and teaching, it was the first time in my career I actually had the luxury of time where I could slow down, look at things, see relationships, and start to remove the variables. I realized our industry is horrible because there's no really good formal education that takes you through step by step. One day, a guy's a carpet installer, he's got good customer service skills, and somebody says, "Hey, how'd you like to be an HVAC technician?" And they teach them all the mechanics. Mechanics fix things with tools. Technicians use technology. An auto technician's going to plug a computer in. An auto mechanic's going to fix your brakes. Two different skill sets. We don't really differentiate that in the HVAC segment. But what I found is in our industry, we have a lot of great mechanics, but we just didn't have any technicians. And the reason we didn't have any technicians is because we didn't really have any technician tools. And that's what I've been building really since I started. And if we're going to improve the industry, that's the direction we got to go.
And so that was the driving force for you to leave TruTech and found measureQuick?
iManifold, the Imperial Tools called me at the time. They're like, "Hey, would you like to come out and design this product for us, this smart connected meter?" And yeah, I'd love to. The owners of that company, we had a pretty bad parting of the ways because they didn't come through with everything they said they were going to come through with. They were good people, just not good business people. It was very interesting because in that whole process, they fired everybody that I worked with at iManifold. So I hired them all because I had money from TruTech. So I actually hired 13 people, worked out of a library for several months, found a place I could work in a dentist office, and bought a whole bunch of $10 tables from Facebook Marketplace and set up shop, had a bunch of used dry erase boards, and we started cranking away. It was about November, the week of Thanksgiving, when everybody got fired. I told them I'd carry them through January till we figured out what was going to go on so that I wouldn't lose any of them. And then got the company spun up and got everybody going by January. And by September, we had the first version of measureQuick and had it out in the market. Had our first contract with the utility that carried us through, and a bunch of us didn't take paychecks for 2 years because it's a startup company, and I still have my same shitty table. I work on it. We bootstrapped this the whole way. We got like 120,000 technicians on measureQuick today, probably around 11 to 16,000 daily active users on the platform. So it's pretty cool. I think changing the trajectory for a lot of technicians, making a lot of lives better, making a lot of these products relevant that I think otherwise wouldn't be relevant. Smart probes, and all you're doing is replacing your display with the display on your phone. It doesn't really help you any. But what we're doing actually makes a big difference.
Congrats on success. Eric and I know what it's like to not take paychecks for 2 years. I love the Ohio version. In Silicon Valley, the startups are started in garages. I've never heard that the Ohio version is starting in a dentist's office.
Oh, yeah.
That's a new one for me.
What's cool is you get a sink in every room. So, yeah.
Awesome.
Jim, I watched your session from a couple of years ago. I think it was called Heat Pump Hell. I was talking to Nate Adams.
Yep.
I think he said, once upon a time, you were Mr. Gasify.
Oh, I still like my gas furnace.
But it seems like you've come around to heat pumps.
I will never not have a heat pump again. The funny thing is my experience with heat pumps was experience with old heat pumps. And old heat pumps sucked. And they were hard to work on. They were never comfortable. They blew cold air. They never seemed to run really well, changing a lot of reversing valves and stuff like that. There's a lot of problems with heat pumps. Now, in all fairness, a lot of them were installation issues, right? I mean, we weren't putting them in right. But today's heat pump is nothing like the heat pumps of yesteryear. Today, with the variable refrigerant flow and inverter technology, and I think what really happened to me was after I got my heat pump, it was the first time I experienced comfort in my house. I've been telling Nate we should ban straight cooling systems. We should just completely eliminate the air conditioner. We should require the industry to transition over to heat pumps because there's always a benefit of the heat pump for the shoulder season period. It's more comfortable and it's cheaper than gas. And it's obviously, we're talking about energy efficiency. I think people got to watch because a heat pump is way more efficient. To put 1 watt in, get 3 to 6 watts out. The electricity is more expensive than gas. So it's this thing, you may not save money with a heat pump, but you do use less energy. There's this money energy balance. It's really hard for people to grasp. So you don't want to tell a consumer, hey, put a heat pump in, you'll save money. That's not necessarily true. Put a heat pump in, you'll be more comfortable and you'll save money in the shoulder season and save money on air conditioning. Yes, that's true. If you were to talk about global warming, I nod and smile. I'm not going to get into that argument over it, but I do believe we should be conserving our resources. There's nothing wrong with using less energy, using less electricity, using less gas, being better conservation of resources. And yeah, it was on borderline of a religious conversion. I hated heat pumps so much. That was my come to Jesus moment when I put the Bosch unit in, and it really exceeded my expectations.
That the piece about there shouldn't be AC units anymore. Everything should be heat pumps at scale. You're talking about $200 to $300 more in manufacturing cost to have a reversing valve and a few other components to just make that happen.
Not even if we did it right, because now you're not retooling lines. You just cut your SKUs down, your inventory costs down. And if you look at the inverter technology, Bosch has got 2 units that do all the way from 9,000 BTUs to 5 tons.
Right.
Right? You know how much carrying cost and inventory that cuts out for them to build a unit like that?
Totally.
I mean, it's insane. And just retooling lines. You don't have to retool a line to build 7 different models.
So maybe it's almost neutral cost in the grand scheme of things.
Yeah. Or even net savings.
Yep. Now that you've gotten a taste of how amazing heat pumps are, why not go the next step?
Because I like gas. I don't know. I guess right now I'm not mature enough in my heat pump experience to go, I'll never want my gas furnace again. I like knowing that it's down there to provide me with either supplemental heat where I do need it, or if your heat pump did go out in the middle of winter and let's say you had a refrigerant leak where you had to evacuate moisture, you would probably be better off running a gas furnace and not servicing a heat pump until you had better weather to service it, because you can't do certain service procedures in the winter. You really should not evacuate a system when it's below freezing. You can't get all the moisture out properly. Now, I have had 0 problems with my heat pump. And theoretically, my heat pump should be as service-free as my refrigerator. If I got the charge right, got the airflow right, got a leak-free system, theoretically, I should not even have to ever touch the refrigeration circuit on that again, and I shouldn't have to do anything but wash my outdoor coil. And I really believe that. But the other thing is, I'm still not 100% convinced we have all the parts availability and stuff down. Parts availability for mini splits is not always easy. It's not like you can just, call up and find a replacement motor or whatever.
Yeah. I'll push you on a couple of things. AHRI data for the last 2 years, heat pumps have outshipped furnaces. At least a lot of the country, there's pretty good supply chain around the replacement parts, that kind of stuff. But there certainly are pockets where that's not the case. It's interesting to see that shift in the market.
If you go to California, that's a giant gas market. Texas, giant gas market.
Right.
What are they thinking? They got all this free energy in the air. Like, those are areas that need heat pumps. No question about it. Right.
Yeah.
It's insane that we'd even think about putting a gas furnace in parts of California. Not all of California. They have mountains. They have areas that you may need other heating. But most of the country, south of Ohio, pretty much, you can get away with a heat pump without even batting an eye. And probably with a cold climate heat pumps, I don't think it's an issue all the way up into Michigan. It's pretty easy to do, but I just don't know the industries where like everybody's ready for it yet.
I'm sure you're doing it on this new place, but do some load calcs, commission the equipment correctly with the tools that you built. You might see that if you get the right equipment, you might not even need electric backup or a gas.
Well, that's what I think is going to happen is I'm going to put the heat pump in and I'll size it properly. I'll probably never run the gas furnace, and I'll probably realize at the end, I think what I'm going to do is I'm going to put an hour meter on the induced draft motor so that I can see how much I actually run my gas furnace. Although it may run during the defrost cycle, so I have to time how long a defrost cycle is so I can deduct that from the metric. But I don't think I'm going to run the gas furnace that often. I agree with you. I was listening to Nate Adams talking about home stock, and there's homes that are heat pump ready, homes that need a little bit of work to get them heat pump ready, and then homes that are the basket case type homes. And what I was thinking though is that almost every home but the basket case home is pretty much heat pump ready. It's just may not be heat pump sole heating, but they are heat pump ready. I mean, I didn't do anything to my house except swap out the outdoor unit. I even reuse my indoor coil and just put a heat pump condenser on. Now, obviously, you can't do that with a new refrigerants, that kind of stuff, but I wouldn't say I prepped my house at all for a heat pump. What it comes down to is, the load calculations are super conservative when we're doing heat load calculations. And what happens is that we aren't taking enough time to actually give the heat loss calculation software all of the extra information it needs so they can trim that load way down. right? I mean, we're basically doing a block load and saying, you know, we're not putting in enough information for it to fine tune the calculation. So we end up with a super conservative number, and then we say, yeah, well, we'll just go up one size. And that's been what the industry's done forever. And until I got that heat pump, I had to put a 90,000 BTU furnace in because I needed a 3-ton drive, because they didn't make a furnace that had a lower BTU input with a 3-ton drive. So I'm thinking, well, I'll modulate all the way to 36,000 BTUs, man. I'm thinking my house is going to be super comfortable. And until I got something that modulated down to 9,000 BTUs, I didn't know what comfort was. Because at 36,000 BTUs, my furnace is cycling at 15 degrees.
Right.
Right.
It's crazy.
So it's with a heat pump, it's on 24 hours a day. The big thing we're missing when we're talking about heat pumps and heat pump technology is, like me, I think a lot of consumers have never experienced comfort. And once you experience true comfort, you don't want to sacrifice that. We like comfortable chairs, comfortable cars. You could give me a multi-million-dollar home, and if it wasn't comfortable, I wouldn't want it. I'd rather be in a little cozy, comfy cabin somewhere with comfortable heat than I would be in a giant home that's miserable. Having an oversized heating system is like having chronic pain, and you learn to live with it. And then when it's gone, you're like, holy cow, this is awesome. Yeah, this is awesome. When I say it was like that come to Jesus moment, that's literally what it was like. I had never experienced that level of comfort in my house, and that's really what converted me. And then it was just the added benefit of the cost savings and that kind of stuff. We're way underselling what I think we should be selling, instead of selling energy efficiency and selling green technology. You're going to be comfortable, and we can match. Now we can match the load with the loads are dynamic. It's the other thing we don't really think about. We talk about heat loss calculation. We talk about like it's a fixed thing. It's only fixed at one set of conditions. And every day is different. So we only get design days 1 or 2 days a year.
Totally. And even within a day it can be changing. There's certain times of the year where you've got, let's say late winter in the Northeast, where you've got snow on the ground, you're getting a bunch of reflected sun off the snow, bunch of solar gain. It can go from being 10 degrees in the morning and 40 degrees later in the day with a ton of solar gain. And if your HVAC system is not responding to that, it's wicked uncomfortable. I remember, growing up where you're opening all the windows and you're closing all the windows and you can't get comfortable through the whole day.
The big thing with the heat pump was just matching the heat loss with the heat gain,
totally. It's continuously variable. It's not like there's 10 steps. It's if you got a heat pump, let's say that has a 8-to-1 or 10-to-1 turn down ratio, say 2,000 BTUs to 20,000 BTUs, you're infinitely adjusting in between those 2 points. So you can perfectly match what the loads are from the outdoor environment to the inside.
And there's so many influences to the heat gain and heat loss of a house. And so matching that up and providing that level of comfort, once you experience it, you never want to go back, so that's why I'm so passionate about it. It's because I had a great experience with it, But I think, one thing to talk about is we are headed for a disaster if we don't get our workforce up to speed when it comes to dehydration of the line set. So pulling a proper vacuum and then getting the airflow right and getting the charge right. Those elements are so critical, along with making sure we have properly sized ductwork. And if we can get the ductwork out of the attic, get it out, because that's just craziness that we ever did that. Get the ductwork in a conditioned space, and just some simple things. But heat pumps don't recover fast. You're not going to get a house down to 40 degrees and turn your heat pump on and have it recovered in 6 hours. It's going to take 24 hours for it to catch up, because it's only got 36,000 BTUs to work with. It doesn't have 100,000 BTUs to work with, right? And what kills me is I've seen refrigerators that are 50, 60 years old. I've seen some that are 100 years old. You still plug them in, they still work today. And why do they do that? Well, they're built at a factory. Somebody paid really close attention to the brazing and making the system really leak-free, and they did a great job with the evacuation, which means they got rid of the chemical factory, because when water and refrigerant and oil mix, it makes acids, and those acids then eat at the copper, and they form a carrier corrosion and create sludge and all kinds of varnish and all kinds of other issues. The only way we eliminate that is we do package units, or we got to really pay much closer attention to how we do the installations. That's going to be our Achilles heel. There's nothing wrong with heat pumps anymore. It's the industry we have to fix.
Yeah. Yeah. And it's amazing to see all the different types of products that are out there within the heat pump category in particular, where you've got ductless units, you've got low static pressure units that, can go in a relatively small space. You can do mixed application. You're ducted and ductless. You've got conventional vertical high static pressure air handlers, and you can do multiple single zone units where you've got a room that has really dynamic loads. You want to have a single outdoor unit serving a single indoor unit in that space, but the rest of the home is set up with being served by another piece of outdoor equipment. And it's incredible the problems that you can solve. And my gosh, I think the number one thing that you've been focused on is that heat pumps are about comfort. That's the magic of heat pumps. It makes your home more comfortable.
You've done a great job painting a picture of how awesome heat pumps can be when done right. There's this interesting thing about heat pumps that we're seeing. We've got customers who are going up against other companies, and they're telling us stories of companies who don't do the design right on heat pumps and are signing an unbelievable amount of release of waivers because they install the heat pump. The homeowner calls 10 times saying, it's not working, I'm not comfortable, it's not working, I'm not comfortable. It gets escalated to the distributor, and when they do the math on it, it looks like just the wrong system was put in. If you put the wrong system in, you'll never recover. And then they give the homeowner 30 or 50% of the cost of the system back. Right. And so heat pumps are in this weird space of when you do them right, they're the best form of HVAC that's ever been invented, but they're easier to get wrong. Other forms of technology. You're the best person I can think of to comment on why that is, Jim, and what we should do about it.
So the worst case scenario is an oversized heat pump on an undersized duct system. To keep it running, you have to remove refrigerant charge, because now removing the refrigerant reduces the efficiency. Duct systems, high static, and it's in heating mode, you're going to have high head pressure. It's going to make the heat pump trip off. And then obviously oversized, you're not going to get any of the benefit of the comfort element of it. If we're talking about like a retrofit, which a lot of these heat pumps, the majority of them are going to be retrofit applications. But if you're not going to modify the ductwork, then if we're going to transition to heat pumps, here's the only thing you got to do. Size for the ductwork. Look close at the supply and return air inlets, fan inlets and outlets. So we want to better design those. Seal very tightly, seal everything downstream to their point of filtration to make sure that you don't pull in dirt past the filter. Oversize the filtering as much as you can. Get the charge in the airflow for evacuation. Make sure that, and I'm a big proponent of pulling down 100 microns, pulling it down to 100 microns with a decay no more than 200 microns. The reason that we pull a vacuum is not as much about degassing it as it is dehydration. When we want to have the dew point down in that 50 to 60 degrees below zero range, because if you think about a heat pump, if it's negative 15 outside, like you are in Maine sometimes, you've got to be 15 degrees colder than that. So you got to be at negative 30 for that heat pump to pull heat out of the air, negative 25, negative 30. Because heat travels from hot to cold, so your outdoor coil has to be colder than the outdoor air in order to pull heat from the outdoor air, which means that your metering device is going to be, or the refrigerant's going to be negative 30. And if you have moisture in that system, it's going to fall out of your metering device and it's going to cause a problem. So with cold climate heat pumps, deep evacuations that we make sure the systems are really dry is really important. Or in the case of especially in the case of a mini split type application, because they don't have built-in filter dryers. And so the only way you can manage moisture when we don't do it through a proper evacuation is through desiccant. Desiccant will get you down to around negative 60 dew point if you have a good dryer. We only have one chance with evacuation, so we got to get it right.
Totally. We saw each other last, Jim, at the building science summer camp, and I met someone who he showed me the data that he was for heat pumps that he's commissioning. He's pulling down to sub 50 and often sub 20 micron because he just really wants to make sure he doesn't have problems.
No, that's the magic right there. I mean, it's just, if you can get doing that evacuation, and there's not, Number one, this is not hard. It's just about some better practices. In our industry, we make things up and we wholeheartedly believe them. And then we tell other people this is the way that it is. And then they believe it. And we pass these misnomers down. And we're like super passionate about things when we're believed them. But when they're proved wrong, we're not as passionate about our apology as we were about what we were wrong about. And that's where I am trying to change, because I was like, hated heat pumps. And I thought they were just inferior technology. Now I'm like, yeah, I was really wrong about that. But I had taken my knowledge of the old heat pumps and put it on the new heat pumps, assuming it was like the same type of technology.
Yeah.
Well, we do this kind of stuff all the time where, heat pumps are hard to work on. Well, you know what the secret is to not work to heat pumps? Is just not having to work on them. If you install and you do proper evacuation, you do a proper charge, you don't really have to work on it. How many times have you worked on your home refrigerator? Why isn't a home refrigerator? Everybody's got one. Why is the industry just booming with maintenance, and why aren't we pulling them out and cleaning behind it? They got it figured out. If you just get the charge right, piping's tight, evacuation's charged, for the most part, they're problem free. There's no between a home refrigerator and a heat pump. It's literally the same thing.
Yeah.
For folks who are building a heat pump focused business, what tactical advice or where would you point them to learn, to get educated, to make sure they build the sort of business that leads to outcomes like you're experiencing in your house right now and not the downside?
Oh, boy, that's a tough. All the complexity of a heat pump now has been managed with better controls with a thermostat. If you get a good stat, so I would say stick with one heat pump manufacturer. Get one that's got variable refrigerant flow. Find a thermostat that you Ecobee, Sensi, and TruFlow Grid with hoses. But it's about find a product, stick with the product, learn the thermostat, and then you got it licked. It really comes down to good installation practices and fundamentals and airflow and heat loss calculations critical. You want to make sure that you're sizing properly. If all else fails, size for the ductwork. Heat pumps are nothing to be scared of. It's just a matter of doing the basics, doing the fundamentals. I don't know that there's nothing more I can tell you than that, because there's nobody that's going to, everything you need to know about heat pumps, you can learn on YouTube today. Honestly, you can. And the interesting thing is consumers are almost becoming more educated than contractors are in some cases, because they're interested in heat pumps. They're interested in comfort. They're interested in carbon footprint reduction, whatever reasons. And they're actually spending more time researching heat pumps than contractors do right now. I think there's a whole market play out there where a contractor could really differentiate themselves and be way ahead of the market. If you're looking to sell in 10 years or something, if you focused heavily now on heat pumps, your company would be exponentially more valuable, because you'd have a crew that could actually provide better install and service than anybody, because you'd have more experience. It's a really good time to consider transitioning over to that kind of technology.
That call to action for folks building HVAC businesses is the perfect place to end the Heat Pump Podcast.
All right.
Jim, thank you. This was awesome. I learned a ton.
Hopefully I didn't babble on too much. I like to talk.
You were spitting wisdom, as they say. This was awesome.
So much fun. Thanks, Jim.
Yeah, thank you guys. Hopefully we can change the industry one contractor at a time.
Thanks for listening to the Heat Pump Podcast. It is a production of Amply Energy. And just a reminder that the opinions voiced were those of our guests or us, depending on who was talking. If you like what you've heard and haven't subscribed, please subscribe in your favorite podcast platform. We'd love to hear from you, so feel free to reach out. You can reach us once again at hello@amply.energy, no.com, just .energy. Thanks a lot.